Today, we're diving into AniTalker, the blazing fast talking head generator that brings faces to life like never before. AniTalker uses identity decoupled facial motion encoding to animate vivid and diverse talking faces. Whether it's for characters in storytelling, avatars, or virtual assistants, AniTalker ensures expressive and realistic facial animations in no time. Experience the magic of instant animation with AniTalker, where speed meets stunning visuals. Stay tuned for more cutting-edge AI tools and innovations.
So this is a new audio to talking head tool, which is released just few hours back. So I did follow the guide, which is mentioned in the README, but it was not working, neither the installation nor the inference. It may be working for Linux, but not for Windows. So I prepared a long guide, and I don't know if it is worth it or not, but yeah, this tool comes with many features which I have not seen in other tools. So let's start with the animation. We will start by cloning the repository. So copy the command which is mentioned in step 1. Now open the folder where you want to install, type cmd in the address bar and press enter. This will bring the command prompt. Paste the command that we copied and press enter. This will clone the repository on local machine. Once the cloning is complete, we'll navigate inside the folder. So paste the command and press enter. Next, we have to create the virtual environment. So we will use conda for that. So copy paste the command mentioned in step 3 and press enter. Now it will ask for confirmation to install. So type Y and press enter. It will take some time. So let's wait for it to finish. Next, we need to activate the virtual environment. So copy paste the command mentioned in step 4, or you can copy it from here as well and press enter. Make sure the virtual environment is activated. Now we have to install some requirements. So copy the command mentioned in step 5, paste in the command prompt. Again, make sure the virtual environment is activated, and then press enter. Now type Y and press enter. Now once the installation is complete, it's time to install some more requirements which we can install by copying the command mentioned in step 6, paste and press enter. Now the requirements are installed. So there is a command to check all the packages which are installed in this specific virtual environment, that is pip list. So if we run this command, we will find out that Torch is installed, but it is installed without CUDA drivers. So let's start fixing this. Copy the command mentioned in step 7, then paste in the command prompt and press enter. Now this will take some time. In the meantime, let's download the pre-trained models. So we need to download these models in the ckpts directory. So navigate to the installed folder, create a new directory, ckpts, then open this link in browser. Now download these 6 files, the extensions of which is ckpt, or the file name is ending with ckpt. So download all of these files in the ckpts folder. So you can click on the download button and then save it in the ckpts folder. So I finished downloading all the files. Just make sure all the 6 files are present in this folder. Next, there is one more step. So there are 2 different type of inference. One is using MFCC and another one is using Hubert. So to run the Hubert demo, we need to download one additional file for testing purpose. So navigate to test underscore demos folder. Here create one directory, that is audios underscore Hubert. And then open this link in the browser and we need to download this in this folder which we created just now. So copy the link, click on download and save in the folder. Now Torch and Torch Vision are successfully installed with CUDA drivers. We can also check it using piplist command. So if we see for both Torch and Torch Vision, we have the CUDA drivers installed. Now we need to fix two more package versions. One is numpy and second is pillow. So copy paste the command mentioned in step 8 and press enter. Now both the packages are successfully installed. Now step 9 is an optional step. So basically if we want to improve the face generated face, then we can install these three packages. If you do not want to install GFP then while inference, don't use this switch. So this switch specifically use GFP to improve the quality. So I will anyway install these packages. So copy the first package, the first command. So need to copy it again. Mentioned in step 9 and press enter. Once the installation is complete, repeat this step for the next command. And now the last package that needs to be installed is GFP. So copy paste the command and press enter. This completes the installation. Now I will close the command prompt. We'll launch it again and do some inference. Now before we start the inference, there are two different type of inference. One is MFCC, which is supposedly faster, and second one is Hubert, which gives better result. So first, what we are going to do is rename this outputs folder. Just change the name to anything, or we can change the output path here, output folder name. Now, why have I renamed it? Because it already contains some sample outputs which are provided. So to start the inference, type CMD in the address bar, press enter. The first thing we need to do is activate the virtual environment. Now, this is the command that is provided. It is also provided here, but this does not work on Windows. So I have updated the command here. The basic syntax is Python, then the inference file. Then there are different type of inference which are available, which you need to read in this document. So there is a detailed guide that is available, and also you can look at the outputs folder, different kind of outputs, and you will understand what changes happens after customizing these parameters. Now we have to provide stage 1 checkpoint path, which always remains the same. It is this stage 1 CKPT. Then there is a stage 2 checkpoint path. So we have just a sec. Yeah. So we have 5 different type of checkpoints depending on whether you are using MFCC or Hubert method. So that can be specified here. And this information is listed in the Readme page. What changes will happen on selecting a particular stage 2 model. Then we have the image path. Next, we have the audio path, result path. Then there is a control flag, seed, pose. So all of this information is detailed in the README page. Now, if we want to improve the face, then use this switch. Otherwise, you can use without this switch. So first inference we will do without using this switch. So copy this command and press enter. VRAM usage is very less. So I guess it will even work on 6 GB of VRAM card. There's only 4.6 GB is used. Now the inference speed is very, very fast. In the meantime, let's look at the audio length. So we are using Mona Lisa.wave. So the duration is 51 seconds, 576 milliseconds. Very interesting. So this is where the output will be created. Processing is now complete and it took only 2 minutes to complete the processing. Now I'm going to repeat the same command with face SR switch. And let's see how much time it will take. The processing is now complete. So it took 1 minute 33 seconds for the actual inference, and then the face enhancement took around 6 minutes. So for the first time, it is going to download some models which are required for GFP GAN. So that's why for the first time, it might take little extra time. Now I'm going to repeat the same steps for Hubert method. There is one extra file that we have specified, that is the NPY file for the Hubert method. So test underscore Hubert path. This is where we have downloaded an extra NPY file, and this needs to be specified. So same, I'm going to try it without the hyphen face SR switch and with the switch. So copy the command, paste and press enter. Processing is complete and it took 1 minute and 32 seconds. Now we will try the same command with face SR switch. Processing is now complete. It took approximately little less than 8 minutes. Let's review the output.
As I sit here, my gaze fixed yet distant, I find myself pondering over the whirlwind of centuries that have swept by, bringing me into an era so starkly different from my own. If I were to stride through the bustling streets of today's world, my presence a curious blend of the past and the present, I wonder, would my enigmatic smile still hold its mystery? In this age of fleeting moments captured and shared in the blink of an eye, would the quiet contemplation I offer still beckon the onlooker to pause and reflect? As the world races by at a pace Leonardo could scarcely have imagined, I muse on the beauty of human connection, the timeless quest for understanding, and the ever-evolving interpretation of art. In this digital age, where every secret seems but a click away, perhaps the true enigma lies in what remains unsaid, in the stories that linger between brush strokes of life.